Fire. Air.
In order to charge our battery pack, we first needed to convert the kinetic energy from wind into electricity. This was achieved by attaching a propeller to a stepper motor. This produced an alternating current, but since our buck boost, a device that ensures a steady 5-volt output, needs DC input, we needed to make another conversion. We first achieved this through rectifiers, but we soon realized that the buck boost in our circuit needed at least 3 volts to operate. Therefore, we switched from rectifiers to voltage quadruplers. In conclusion, we knew going into this project that it was pretty ambitious. To quote Chris, power equals problems. However, given these limitations, we were all really excited that we managed to achieve a proof of concept for the power generation and that we were able to display relevant data.
When we then tried to charge our device, we ran into some problems, and particularly, as the input voltage approached the required 3 volts, the output voltage spiked up but was unable to remain there. After many hours of troubleshooting and finally measuring the current, we found that the current was only 0.4 milliamps, but the buck boost needed at least 22 milliamps to operate. Furthermore, as Ben beautifully pointed out, 0.4 is less than 22. Therefore, we were able to conclude that our motor did not generate enough energy to power dissipation across the quadruplers, the buck boost itself, and charge our device at the same time. To achieve a proof of concept, however, we modeled a scenario in which the motor did generate enough power by plugging in 2 1.5 volt batteries into the buck boost, and as can be seen here, the device charged successfully.
Alright, so now we can actually see the wind measurement device in action. So the way this functions is the blades will disrupt the laser tripwire, and you count how many times in the sequence you get this in order to count the RPM. In this case, since we have 4 blades on our turbine, we're able to calculate the RPM by taking the time it takes for 4 disruptions of the laser. Then we're able to display that wind speed to the left on the display. Another feature of this display is it has a toggle switch, so now we're looking at the temperature in Celsius. And then once we actually try to increase the temperature using the hairdryer to the left, you can see that the temperature goes way up, and it's updating continuously as it's on that toggle. Now we go to the next point. We can see here, this is the pressure. In this case, we clearly weren't sampling at a good frequency. We can see some aliasing occurring on the blade here, so we should really move to a Nyquist sampling frequency. And as we speed up there, we can actually see that it stops aliasing.